In lesson 3, we are going to review evaluating expressions and adding like terms. Does anybody remember the difference between an expression and an equation? What are we going to have on that one, Milo? Okay, an expression, all you can do is simplify. An equation you can try to solve. Can anybody tell me another difference in the two? Naomi? The equation it starts out like an equal. That's when we have something equals something else. An expression, we don't have an equal sign, or we just have the expression equals and we don't have the second side. So it can be written both ways, but the equation, we've got to have something equals something else, or it's not possible to solve it. Expressions can have just numbers that we simplify. 2 times 3. Well, we could simplify that and say 6. Or it could have just letters, and maybe we can put them together, maybe we can't, depending on whether they're what we call like terms. Maybe it has numbers and letters, as we were just saying, just one side, either with or without an equal sign right after that. So it's kind of like a sentence fragment or just a phrase in your language arts classes. So x plus 4 is an expression. 3x squared plus 16xy minus 3y plus 12, that's an expression. Can't simplify either one of those any farther, but you see what I mean about numbers and letters. Like terms are the ones that we can combine. They have all of the same variables with the same powers. The coefficient, the number in front, can be different, like the 3 and the -2, but they both have x squared and y and z. The order was changed for z and y, but they still each just have one of those that are multiplied. X, y squared z would not be a like term because it's x squared in one and x in the other, and y in one and y squared in the other. So each letter with its exponent must match. If I were putting those together, let's suppose that it said 3x squared yz plus the -2 x squared zy. Who remembers what we would do to add those together since they are like terms? Chloe? You'd say, okay, they're all x square yz's, and we'd look at the coefficients. 3 minus 2 would just be 1, and we don't really need to write a 1 whenever that is the coefficient, but that's what that would mean. So that's part of what we're reviewing today. Evaluate an expression is when they give us the expression ab squared minus b, and then they tell us what they want us to plug in. So it's just a formula, plug in. So we're going to change the a to a 2. B squared means b times b. We're going to be a little bit careful because b is negative, and then minus the -3. I often find it helpful when I have minuses to say I need a, and then I need b squared, and then I need minus b, and then put it into the parentheses. It helps me not mess up the minuses. You don't have to do that, but if you find you're having trouble with minus signs, you can certainly do that step in there. This means b times b. So it means -3 times -3, which is everybody. And then times the 2 is, and minus -3. What do I do with that? Everybody. It's a +3. And so final answer for this evaluation is, so that's definitely coming back nicely to you guys on how we're going to do that. Let's do another one, a little bit longer and messier. So we're going to do the very same thing with these. We're going to put 2 in for the x's, -3 for the y's. So I'm going to have a 2 for the x and a -3 for the y. Then I have this minus sign out here, And I'm just going to go through and plug everything in first. Then I have minus the 2 times a minus 3 plus a minus 3, and then I need to close that whole parentheses. 2 times negative 3 is how much, everyone? Negative 6. Now, it works either way. I could go ahead and distribute the minus sign to each part inside here, but I am going to actually choose to do PEMDAS and simplify what's inside the parentheses first. It's just numbers, so I can put them together. What is negative 2 times negative 3? It's a positive 6 plus a negative 3. So inside the parentheses, what do I have? 3. Then I've got the minus sign that was out front, and I still have the minus 6. And what does that equal? Negative 9. Does that make sense? And to me, that's a little bit easier than trying to say it's a negative 6 plus a minus 6 and a plus 3. If you can simplify everything that's in the parentheses, do just that part. Okay, let's add like terms. I need some help finding the like terms in this one. Tay, I'm wondering if you can tell me 2 terms that we would call like terms that we could put together. And let's be a little bit careful because the minus is part of the 6yx one. So 3xy and minus 6yx. And what do we get if we put those 2 together? Excellent, thank you. And so we've used those 2. Are there any more like terms in this particular one, Cosmo? And be a little bit careful again. Negative 2x and plus 3x. And what do we get if we put those together? Just a 1x. So we just write a plus x. And we've used those. That also leaves us a plus 4. Nothing else left. So we can't combine it with anything. And we have added our like terms there. Okay, let's do one more that's kind of weird. What happened to my one more? Ah, there it is. All right, so with this one, I'm not sure what is a like term and what isn't. I'm going to first make sure I rewrite everything with only positive exponents so I can see what matches up. So first term, 2a to the minus 3x over m. Manas, would you help me clean that one up, please? Just this one. So what would I have? Just dictate what I write. Uh-huh. And then let's go on to the next one. Nitsa? Mm-hmm. There you go. Special delivery. Okay, next one only has positive exponents, so I'm going to leave it just like it is. What about the last one? Han, can you help me clean that one up, please? Now I'm looking for letters with the same exponents and in the same place as far as numerator or denominator. Are there any of those that match up? Like first, last, second, third? What are we going to have there, Khadijah? And so what would we get if we combine those? So the 2 of them minus 5 of them, we would have minus 3x over a cubed m plus a cubed m over x. Does that sound good? All right, I'm not going to take time to hand out whiteboards, but I am going to have you guys do a couple of these on your own papers and see if we can come up with the right answers. So let's do this one. And it looks like most of the writing has stopped. So I need some help figuring out which ones are the like terms for this thing. So I only see one negative exponent in there. So we need to start with cleaning up that first term. Lucy, what did you do with the first term? Okay, so you got rid of that right here and put it here. Now, who can tell me which terms are the like terms in that whole thing? Anna, which ones did you think are like terms? Everybody good with the first three? And so we have 3 of them, minus 4 of them, plus 7 of them. So how many of them altogether, everybody? So we ended up with 6 of the first terms, which were b over a squared c minus 4 a squared b over c. Questions with that? All right, and just for a little bit of review on some vocabulary, draw those 4 on your papers and label beside them which is which: VA, AIA, AEA, and Core A. And then I'll get some volunteers to put them up on the backboard of which one is which. Angles. For the vertical angles, you just draw 2 straight lines that cross, and then opposite ones you label. So if I'm asking you to draw a picture, that's really all you have to do. You don't have to worry about the numbers and everything. I just want us to be able to tell when we looked back there which picture is corresponding, which one's alternate interior, and all of that. Alternate interiors would be something like these 2 inside the parallel lines, but opposite sides of the transversal. And these 2 happen to both be obtuse, the way that it was drawn on the backboard and labeled and the way I've got it up here, but we could have picked these 2 acute ones. Alternate exteriors means they have to be outside, so we could pick something like this one and this one, or we could have picked the 2 acute ones there, but they have to be exterior, outside, opposite sides. So of the outside ones, 2 that are acute, 2 that are obtuse. And then finally corresponding, she put it up with northwest on both, so we could have both of those. Any questions with that? Okay, be sure you know the vocabulary going into the test next week. We're going to stop here, and the rest of our time is for working on homework.